Question 9 on homework 5A. Once again, we are finding all real and complex solutions for the following polynomial equation. It gives me directions about how to enter the answer. And so here is the problem. It says, if we solve w cubed minus 216 equals 0 for w, then it's asking for the real and imaginary zeros. So as I explained in the last video, we cannot just get the w by itself and then take the cubed root of both sides. We can only do that with square roots. So in this situation, I am looking for ways to factor this down if possible. And in this case, we can factor. This is the difference of cubes because 216 is you can take the cubed root of that, and you will get, let's see, 216 to the 1/3 is 6. So w is the perfect cube here, and then we have 6. And so we just need to remember our formula for the difference of cubes. And remember, you can, there is a formula for the sum and difference of cubes. So what it is you're going to do, if it's minus, then I remember it as minus plus plus. And if it's plus, then it's plus minus plus for the signs. Everything else is the same. So for a minus or a difference of cubes, you're going to have the first one, which is w, minus, and then the cubed root of the second one, minus 6, and then you're going to multiply that by a trinomial, which is going to be the first one squared, so w squared, and this is minus plus plus, so this is where that comes in. It's going to be w squared plus the first times the second, so 6w, and then plus the second squared, which 6 times 6 is 36. So we have w minus 6 times w squared plus 6w plus 36. And now that I have this factored down, I can just set each one of these equal to 0 and solve. So this one's pretty straightforward. W minus 6, when I set that equal to 0, I'm going to get w equals 6. So that's one of my solutions. And then I want to set this one equal to 0. And I am trying to solve for w here. And so I'm just trying to think about the best way to go about this. First, I want to see if it can be factored at all. Factors of 36 would be 6 and 6, but I want them to add to 6, so that won't work. Another factor of 36 would be 9 and 4, which those do not work either. 36 divided by 2 is 18. 2 and 18, those don't work. So I'm going to go ahead and I'm going to have to use the quadratic formula or a different method like completing the square. Since these numbers are pretty straightforward and I already have a coefficient of 1, I'll go ahead and practice completing the square for this one. So to complete the square, this will stay the same. I'm going to leave a space here, and I'm going to move the 36 to the other side. Off to the side, I'm going to do some work. I'm looking for b over 2 squared. b is 6, so I have 6 over 2 squared. 6 divided by 2 is 3. 3 squared is 9. So what I'm going to do is add 9 to both sides. Okay. Then what I can do is I should now be able to factor this side on the left. So I have 9. And factors of 9 that add to 6 are going to be w plus 3 squared. And this is your goal here, is to get it into a binomial squared. And then that is equal to now negative 27. Now that I have it in this form, I can, since this is a square root, I can take the square root of both sides. And so I get w plus 3 equals plus or minus. This is a negative, so I'm going to take out an I. 27 also can be factored into 3 and 9, and of course 9 factors down to 3 and 3, so I can take out a 3. Actually, I'm going to squeeze that here, plus or minus 3i with a 3 still left on the inside. And then I can subtract the 3 from both sides, and I get w equals negative 3 plus or minus 3i square root of 3. And so since these have this has an I in it, this is what it's referring to as our imaginary zeros. So if we go up here and look at the answers, the real zeros of the polynomial are this w equals 6 is our real component. And then for the imaginary zeros, we have 2, we have negative 3 minus 3i square root of 3, and negative 3 plus 3i square root of 3. So that is how I got my answer here, and I plugged it in, separated it by a comma, no space, and that is it.